Good morning, Innoverson. Send in group the message that class started. We'll start with numericals. We'll start with numericals today. Shall we start with numericals? Now look here, first numerical for today. Good morning, Ashwita. Let's start, beta. How will you join three resistance of resistance? How will you join three resistors? Join three resistors. So you have to join three resistors of resistance. Okay, so you have to join three resistors of resistance 4 ohm. Good morning, Jotam. 4 ohm. Come on, start solving the question. 4 ohm, 6 ohm, and 12 ohm to get an equivalent resistance of to get an equivalent resistance of to get an equivalent resistance of 8 ohm. This is the first part of the question. So they're asking that, okay, how will you join 4 ohm, 6 ohm, and 12 ohm to get an equivalent resistance of 12 ohm? So 100% here, series connection will not be there, because in series connection, if you will be joining, the resistance will become higher. So it's not going to work. So now what work we are going to do? We are going to connect it in which connection? Come on, say everyone. Join as fast as possible first. What is this? Good morning. Parallel and series. Wow. Let's check this one out. Super. Jasmita has told it is going to be both parallel and series. That's nice answer. That means we have to connect it in parallel also, and we have to connect it in series also. But Peter, can I ask you a question? How can you come to know we have to connect it in parallel also and series also? And which one should be connected in parallel and which one should be connected in series? Because we should be knowing now which one should be connected in parallel and which one should be connected in series. You say. Second part of the question is, this is the first part of the question. The second part of the question is, what would be the highest and the lowest? What would be the highest and the lowest equivalent resistance? What would be the highest and the lowest equivalent resistance? Super. Very good. Let's check, let's check. I did not read that. I'm going to read that. Nice, Aswita. Super. So what would be the highest and the lowest equivalent resistance possible by joining these resistors? Come, beta. Possible by joining these resistors. So these are very important things. Come on, check this one out. So little bit move beta from that camera side. Shake, miss. Now look here. Yes. Good morning, ma'am. So definitely this is one of the most important questions, and I was unable to read the answers. Ashwita is telling one thing, that is 6 ohm resistors and 12 ohm resistors in parallel, 4 ohm resistors in series connection, 6 and 12 parallel and 4 in series. Very good. So let's check this one out. How we come to know that answer you have not given? See, because if we will be totally connecting in parallel, if we are connecting in parallel everything, it is not going to work. The most important thing is, if we are going to connecting in parallel, it is not going to work. If we are going to connect totally in series, it is not going to work. So we should find a middle way out, where we can find, because they asked 8 ohm. The concept here is 8 ohm. So now if I will do 6 and 12, if I am going to connect in series, 6 and 12, I'm going to connect in series. I'm going to start with what the girls has said, 6 and 12. Connected in series or parallel. Parallel I'm going to connect, and 4 ohm I'm going to keep like this. Okay, fine. So now we are going to do one work, that this is coming in this is coming in what, parallel. So 1 by 6 plus 1 by 12 is equal to 1 by resistance of AB part. Okay, so resistance of AB part. So 1 by resistance of AB part is equal to 12 plus 6 by 72. So 1 by resistance in AB part is equal to 18 by 72. So resistance in AB part is coming as 72 by 18. 6 3s are 18. 6 1s are 6. 6 2s are 12. 4. So now it is coming, RAB is coming as 4. And 4 plus 4, Divya, good morning. 4 plus 4 will come. So now, if we are resolving the circuit, it is already we have written as 4 ohm. Now another one is coming as 4 ohm. So total it is coming as 8 ohm. That's correct. So we are now in a situation where we can be able to write it as 8 ohm. Vishwa, good morning, Vishwa. So now it is coming as 8 ohm. So this was the question, and how we are going to encounter the question. In examination, what is most important is your presence of mind. Understood? And what they ask, how you are going to deliver, that is also very, very important. How they are asking and how you are writing, that is the most important thing. So you need to answer perfectly. Okay. Now what next question they are telling you is, what would be the highest and what will be the lowest equivalent resistance. So when the case they are asking, Vishwa, what will be the highest and what will be the lowest, what case we will be doing? One time we will be connecting it with series, and one time we will connect it with parallel, because series will give you the highest equivalent resistance and parallel will give you the lowest equivalent resistance. That's exactly most important here. I hope you might have understood here. So now this is the first part of the answer. Now, second part of the answer. In board examination, now slowly I'm going to teach you how to handle the question and how to write perfect answer. Because when you will be writing perfectly, definitely scores will come perfectly. So now the second part of it, now check this one out. What will be the highest resistance and what will be the lowest resistance? So highest resistance we will get corrected in series. So when connected in series, we are going to get highest resistance. Good morning, Beta. So when connected in series, we are going to get highest resistance. So highest resistance will come, equivalent resistance will come, highest resistance as 4 plus 6 plus 12. So total coming as 22 ohm. Got it? Now the second part of it, lowest resistance. So lowest resistance, how we are going to get? Lowest resistance 1 by 4, 1 by 6, 1 by 12. So 4, 6 and 12. So how much it is coming? Check. 6 by 12. So definitely 1 by equivalent resistance is equal to 1 by 2. So equivalent resistance is coming as 2 ohm. So here in this situation, the resistance is coming as 2 ohm. So highest is coming as 22 and the lowest one is coming as, highest is coming as 22 or 24? 22, na? Check this one out. I think it is coming 22 only. Addition is there, yeah. Highest is 22 because 6 and 12 and 4 is there. So 6 plus 4 is 10, 10 plus 12 is 22. So highest is 22 and lowest is 2. That was is the question. That was the question. Highest and lowest, and definitely how we can get desirable resistance if they are asking, we can do like that. Desirable resistance when they are asking, we can do like that. Don't leave this type of content. We must solve this type of content. I hope you might have understood this one. Come on, shall we go for the next question, please? Ready? Oh, we are done. Now we are going to go for the next question. Question is, how many bulbs? Ready? How many bulbs? Come on, children. How many bulbs? How many bulbs of resistance? Write down the question very carefully. How many bulbs of resistance 6 ohm should be? 6 ohm should be joined in parallel. 6 ohm should be joined in parallel to draw a current of 2 ampere. To draw a current of 2 ampere. To draw a current of 2 ampere from a battery of 3 volts. And your time starts now. Everyone, come on, go for it. Maximum time given is only 1 minute. In 1 minute, you have to solve this question. If you are unable to solve, means I am going to solve. Can I solve? Online children, inform the students to join as fast as possible. Everyone, come on. How many bulbs? 4 bulbs. Very good. Super. So let's see. Is it going to be correct? Here, Ovian told 4 bulbs. What about others? So what is the way of writing? What is the way of writing? So here, first understand beta. What they have given is current and this one is given. So first with the help of these two in solution section, what is given to us with the help of that two, we will be first able to find out. Good morning. We will first able to find out V volt given is 3 volts. Understood. Current given is 2 ampere. So V is equal to IR. Resistance is equal to what coming? V is 3 volt, 3 by 2. So definitely it is coming 1.5 ohm. So every bulb will have resistance of how much? The total resistance, entire resistance is supposed to be how much, beta? Understood. So 1.5 is the resistance. 1.5 is resistance of what? 1.5 is the resistance of entire one now. V is equal to IR. So 1 by 5, 1.5 is the resistance of the entire circuit. It's the resistance of the entire circuit. Come on. Understood. That is called as equivalent resistance. This is nothing but equivalent resistance. Note down, please, children. That is considered as what? Equivalent resistance. Now, how much it is exactly there? So they are telling that 1 by 1.5 equivalent resistance is equal to maybe R1 bulb, R2 bulb, R3 resistance like this to n times connected Rn. And each one is having what? Each one is having resistance of 6 ohm. Each one is having resistance. See how many bulbs of resistance? 6 ohm. So every bulb is having resistance of what? 6 ohm. So 6 ohm, 6 ohm, 6 ohm come on having how many times? N times. So if something is 1 by 2, 1 by 2, 1 by 2, 1 by 2, if you are adding, it will become what? 1, 2, 3, 4, 4 by 2. So here every bulb is having resistance of 6 ohm. So how many times we can add? N times, because we don't know how many bulbs are there. So let the number of bulbs be, let the number of bulbs be n. So these many type it is going to add. So how much it will come? N by 6. Correct? So now, because this one is coming 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. How many times it is coming? N times. So it will become n by 6. So definitely n will be equal to 1.5 by 6. Correct only now. So n will come 6 by 1.5. Sorry. 6 by 1.5. So 4. So absolutely correct answer. It is coming as 4. But what is the way of writing is most important. It's not like you can write anything. It's not like you can write anything in examination. You have to write with the very precise thing. First, you had to find the equivalent resistance. Equivalent resistance, how much you got? 1.5 ohms. After equivalent resistance, you have to arrange it in a very systematic way. 1 by equivalent resistance is equal to 1 by R1, R2, R3, R4. What is R1, R2, R3, R4? Different bulbs. But every bulb is having what resistance? 6 ohm. So 1 by 6, 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 n times. Because we don't know the number of bulb. So we are going to assume it, let the number of bulb be n. So n by 6 will come. And after solving, how many bulbs are coming? 4 bulbs are coming. That's most important part. You need to keep on checking these sections. This is very prominent. See, today very important numerical session I have kept. And seriously, I'm getting very angry because you people are not here. So seriously, this is not good. This is actually not good, the way you people are treating. Yes. Now another question I'm going to do. Write down the next question. Get ready for the next question. This one done now. Okay. So now the third numerical. Everyone, please pay attention. If your numerical power is strong, means you will be. Okay, last part I should teach one more time. In last part, what was there is ki once you got equivalent resistance once you got is 1.5 ohm. That means that means what you are writing the formula, how you are writing the formula. You are writing this as na ki 1 by R1, 1 by R2, 1 by R3. So now look here, Tarun. We don't know how many are connected in parallel. So we will do like this. Maybe like this many are connected in parallel. Okay, maybe like this many are connected in parallel, but we don't know. So what we are going to do, maybe like this many are connected in parallel. So how many we can, so let the number of bulbs connected is, let the number of bulbs connected be. Okay, so if the number of bulbs connected be n, that means each bulb will have some resistance, but they said equal resistance. What resistance? Equal resistance. So each bulb is having n resistance. Then what we are going to do here is, we will be writing 1 by R4, 1 by R5 till 1 by Rn, because we don't know how many resistance bulbs are there. So each one is having 1 by 6. To how many times? N times. So here it is, equivalence is 1 by 5. So here if it is coming 1 by n times, so this one is repeating how many times? N times. So directly it will become n by 6. So now you have to just shift 6 by 1.5 is equal to n. After solving, decimal 0 will cut 410, and after solving n is coming as 4. So this is a way, this is a technique of writing the answer. This is a way, this is a technique of writing the answer, and you must be knowing how to solve these questions. Tarun? Yes. Now is it okay? Very good. So shall we go for the next numericals, please, children? Now listen. The numerical sessions are very, very important. Understood? Now I'm going to do one question. Note down this one. Just draw this first. Huh? In group, nobody put message. How possible? Nobody messaged. No, everyday class will be there. It's not like that. Okay. Everyday class will be there. It's not like that. If my health is not good, if any problem is there, that time only class will not be there. Exams are near here. In fact, you saw Sunday, na? Huh? So definitely pre-board and all those times, I will be 100% with you people. Where I will go. Do it very particularly, please. Draw it first. First, draw the circuit. After drawing the circuit, right, consider the circuit as shown in the figure. Good morning, Kavya. Consider the circuit as shown in the figure. The voltmeter on the left side reads 10 volt. The voltmeter on the left side is reading how much volt? 10 volt. And the right side is reading how much? 8 volt. Now, what is the question? The first part of the question is, you need to read the circuit, and after that you have to start writing the answer. Yes, and you have to start writing the answer. First, the current through the resistance R. Nice decision to come, sir. That's a very good decision. Yes, a 10 volt and see here this how much it is there, beta? 10 volt, and how much it is there? 8 volt. Okay. So now what is the next part they are telling that the current through the resistance R. First, what you have to calculate? You have to calculate all these things. Calculate. First part is the current through resistance R, beta. Second is the value of R. Second part of the question. This will come as a case study. The value of R. Third one, the potential difference across the battery. Across the battery. Come on, go for it, children. You can do it. Come on. Start doing it, please. The potential difference across the battery. Start your work, please. Huh? Yeah, calculate current through the resistance R. How much current is passing through the resistance R? Okay. Through the resistance R, you have to find current. These questions are seriously very, very difficult questions to answer. Correct, na? Directly in NCERT book, is this given? No. But in the exam, if it is coming means 100% you need to have that type. Like you need to have that. You need to understand how to solve these questions. Come on, go for it, please. So first is the current through, what work is exactly there? The current through resistance R. So one by one, we are going to first understand in board exam how you are going to write the answer. The biggest challenge is in board exam how you are going to answer the question. That's the most important thing. So your board exam preparation is most important. So first thing is that beta, they told that the current through the resistance R. So now how we are going to write the solution? So writing solution is one of the most important target. So the first thing is that how you are going to indicate today where is Vishwa yaar? Jotam is there, Vishwa is there, but all people are vanished today. Nobody is saying one word also. Answer is coming 2 ohms. Very good elaboration. Kavya is also telling 2 ohms. Now let's see. First we are going to see. See how to write the perfect answer. That's most important. And for that, what work we need to do? First important work is we need to explain that these two resistors are connected in series. These two resistors are connected in series. Don't say voltmeter, yeah. Voltmeter will be connected in parallel. 2 ampere. Now look here, current they are asking now. See, look here. The first thing is, we have to write this part. Since R and R1 is equal to 4 ohm, resistors are connected in series. They are what? They are connected in series. So since they are connected in series, so resistance remains, current flow remains same. So in series connection, the amount of current flow remains same. So I remains same in the circuit. So now this one can help us. This one can help us. So V is equal to IR1. V is how much given? 8. Resistance is 4. I. So 8 by 4 is equal to I is equal to 2 ampere. Correct, na? So the most important thing is yes, absolutely correct. So this is the first part of the answer. This is first part of the answer. How to give a perfect answer, write the perfect answer. See, only solving the numerical is not there. In examination, how you have to do. First, no matter they have given this circuit, no matter they have given this circuit, what is your duty is when they have given this circuit, you have to draw it again. Remember, draw it again. After drawing it, first part, write this like this. Directly don't solve. They'll not give you marks. Understood? They'll cut marks because you have not explained the preliminary sections. How it is A is coming common, because both are connected in series. So since both are connected in series, current remains same. So current remains same means one particular resistor is enough to get the current. Correct now? So we use this resistance to get the current. That part is done. Now next part, value of R. So value of R, how we are going to come to know? Value of R. So now we have, listen children, now we have total amount of current and current remains the same. Now we have total potential difference. What is the total potential difference? The total potential difference will become 18. Correct now? Because here this is 10 and this is 8. Correct now? So total potential difference will be V is equal to V1 plus V2. So total potential difference across the battery. See, potential difference they are asking here. Correct now? So potential difference they are asking here. One work we can do now. Current. So first we will calculate this one and we will calculate this one. Correct now? So can we take this as help? So we know that V is equal to IR. For resistance, R. V at that case is how much? 10. Look here. When look here, beta. This is exactly how much given? 10. And how much resistance is there? We don't know. But current remains same. So current amount is how much? 2 ampere. So here we will write V is exactly coming as 10 is equal to 2 into R. So what is the resistance coming, beta? 5 ampere. Sorry, 5 ohms. 5 ohms is the current coming. Now what is the potential difference? The total potential difference. This is second answer. What is the third answer? Total potential. So total potential difference is coming as how much? 18 volts. Total potential difference is coming how much? 18 volts. And that's very important. So numerical grip is very, very important because board examination, electricity, magnetism, carbonics, compound, these chapters are very, very important. If you don't have grip in their part, then 100% you will be losing. So definitely listen my words very carefully. What you need is a perfect pace of writing the answer. You should not be writing here and there. Okay, now next question is, come on, go for the next question. Are you all ready for the next question? Come on, say me yes. So this one question, second question and third question we did now. We did with our own pace, we did it with our own understanding. So now we are going to go for the next question. Get ready, beta. So some typical questions we have solved. Yes, super. So now we are going to solve one more question like this. Let's see how you are going to do it. Question is three identical bulbs. Write down. Three identical bulbs are connected in parallel. Three identical bulbs are connected in parallel with a battery. Three identical bulbs. So three identical bulbs are connected in parallel with each other with a battery. So what it is exactly there? What was there with a battery? With a battery. Understood. So they are the current drawn from a battery is 6 ampere. The current drawn from a battery is how much ampere, beta? 6 ampere. After that, right, if one of the bulb get fused, this type questions they're asking actually. If one of the bulb get fused, so beta, if one of the bulb is getting fused, come on, so after that what they are telling, what will be the total current from the battery? What will be the what will be the total current from the battery? Come on, go for it. All are connected in parallel. If one of them will be fused, solve it. Try this question. Hmm? What? All will have same resistance. Identical means all will have same resistance. Can I solve? If this type of questions are coming, don't check net, don't check anywhere, try to solve on your own, because if you will be seeing net, if you will be seeing anywhere, you will not be learning. So first, the better important conclusion here is, better first search your brain, what and all to be done here, basic, collect the basic informations, and then you will be able to solve the question. So first important preliminary section is search the basic informations, what and all basic informations are there. First you need to search that basic information. The first basic information given to us is, which we are going to collect, is कि the three identical bulbs are connected in parallel. That means कि each bulb is having resistance R. Correct now? So we will write like that only. First information is, first we will draw. First what work we are going to do? We will draw that part. So now in solution section, the first part is drawing. So how we are going to draw, beta? So we'll write first, let each bulb have resistance R. So beta, let each bulb is having resistance R. Every bulb is having how much resistance, beta? R. Now we are going to draw it. I hope my children are understanding this. So beta, first we will draw. So this is exactly the first bulb. The second bulb. Done everyone? Now look here, beta. So this will be getting connected. All the three bulbs are connected. Till here no problem now. All the three bulbs are connected. So now each bulb is having resistance R beta. And every time current is I, so this part will become I1, I2, I3. So currents moving in the circuit is I1, I2, and I3. And this is the total potential difference V. So potential remains same. What remains same here, beta? For parallel connection, potential remains same. Okay. So now also in parallel connection, In parallel connection, what remains same, beta? I am fine, Himanshu, solve karo numerical. Parallel connection, the potential difference remains same. The potential difference is not at all changing. So if the potential difference is not changing, it is exactly good for us now. So how we are going to find the resistance? Three bulbs are having equivalent resistance. First we'll find 1 by equivalent resistance is equal to 1 by R plus 1 by R plus 1 by R. So it is coming how much, beta? Equivalent resistance is coming as 3 by R. So equivalent resistance is coming as R by 3. We will take it as equation 1. Now, beta, we know that V is equal to IR. Yes, V remains same. Yes, absolutely correct. Now, we know that V is equal to IR. So, here R will become equivalent resistance. Understood? So, V remains same. Talking about, got it? So, R is coming as how much, beta? R by 3. Absolute, no? So here current is exactly coming as how much, beta? So V is equal to current part, if somebody will be asking you, so 3V by R, current will become how much? 3V by R. Any other information they have given? So I drawn from the battery, current drawn from the battery is 6 ampere. So overall current is given as how much? 6 ampere. Can we check? Can we substitute there? So V is equal to 6 by 3 into R. How much it is coming? 2. So V by R is equal to 2. Correct, na? 2 ampere. V by R is equal to coming as 2 ampere. Now, one of the bulb is getting damaged. Understand? One of the bulb is getting damaged. So let's see the first bulb getting damaged. How many bulbs are left, beta? If one bulb will get damaged, how many bulbs are left? Two bulbs are left. Understood? So if one bulb get damaged, so write the second part of the question. If one bulb get damaged, then since it is in parallel connection, since it is in which connection, beta? Parallel connection. Since it is in parallel connection, the remaining two bulbs will glow without interruption. Correct, na? The remaining two bulbs will glow without interruption. That's the most important thing. The remaining two bulbs will glow. Then what will be the resistance in this case? So this time the new resistance R1 will be exactly coming as 1 by R plus 1 by R, beta. Done? So now that means 1 by R1 is equal to 2 by R. So R1 is equal to R by 2. This is what case? This was the first case. Now this is coming as second case. Now beta, what is the potential difference? The potential difference in that case will be V is equal to IR1. Correct? V is equal to IR1. Now beta, R1 is R by 2. V, I is how much? 6. So we will write overall the circuit is having 6 ohms into R by 2. 6 into, this is R by 2. So if you are writing like this, how much it is coming? V by R is coming as 3. But we can't write like that, na? They are asking what asking total current from the battery. So here current value we can't put 6. Are you understanding? We can't put 6 value as current value. We have to find that only. Ovian. Understood? So we can't put 6 there. So that is coming as R1 is coming as R by 2. That's actually we have to find. Yes, potential difference is same. So here again, we can write V by R. This time it is coming as I by 2. V by R is equal to I by 2. This condition is coming as equation 3. Understood? So from 1 and 3, what we can write, patiently solve this part. See, first part, from the first equation, when all the three bulbs were glowing, we got V by R is equal to, we got V by R is equal to 2. When two bulbs were glowing, if one bulb got damaged, two bulbs are glowing, we got V by R is equal to I by 2. So from equation 1 and 3. Equation 1 and 3, what is coming beta? Here V by R will get common, so it will become 2 is equal to I by 2. So I is equal to 4 ampere. So you need to be very clear in your concept. Yes, beta. So if one bulb, correct Himanshu, if one bulb get damaged in a parallel connection, the remaining bulb will continuously grow without interruption because it is exactly connected in series. In parallel. In one word itself, you can rest the entire situation. That you can say that it is connected in parallel, because of that this situation is there. That's called as what? This is exactly the concept. So how was the question? Did you understood the question? Now? In exam, beta, if they will ask means कि my student should be the first one who can answer the question. Equal to IR, so V is coming as R by 3, so that R part is there, and here V by R section, one time section containing this part, this part. So is it easy for us to solve the question if they are asking this type of questions? Correct or wrong? Yes. So now we are going to talk about electric power. Yes. Is it coming lag? Oh, network, some problems are there. I'm going to take care of network problem. Here, yeah, it's not a problem. The camera is having problem. Net speed is exactly getting low. Camera is capturing the net speed now, so sometimes lag is coming. So I am connecting laptop with that camera partner. So lag we are trying to remove. Now can I start the next work, beta? Come on, check this one out. Now is it? Yeah. Wait 1 minute. Then at that particular moment, yeah, we will do marathon. At that particular moment, what we will do is what and all questions are left. Nearly 200, 300 questions we will solve. Like in maths, how we did. So it will give you confidence. Okay. So definitely, because science exam, we don't have too much time gap in between them. So we need to understand that before science exam, we have to practice as much as possible, because before science exam, Tamil exam is there, and children who are having Tamil, they will not be getting time. So January, February, full science fully finished. Huh? Hindi children also not having. How many time gap is there for Hindi children? After science only they are having Hindi exam. We'll manage now. See, now it's November, December, January, February. We are in, see, major chapters I'm teaching very slow. Why? Electricity, magnetism, carbonates compound. That chapters I want to go slow. I don't want to jump in that and run in that, because with this pace we will start revising the previous chapter. Start. What happened? Exam timing is what? But now can you check? Yeah, some problem is there. Lag is coming. Himanshu, you are correct only. My network is slow. Let me check. It's very slow. Now, is it okay? Just 1 minute here. Just give 1 minute. Yeah. Now look here. We are going to understand what is electric power. See, electric power. So if somebody will ask you what is your power, you will simply say that I can carry 80 kg. Some people will say I can carry 100 kg. That's my power. Understood? So power is related to how much work you are doing in certain time interval. Correct now? So some people will say I can carry 120 kg. Correct now? So that weightlifters will be there. If we will ask their power means what is the simple answer what they are going to give? They'll say that we can carry 100 kgs. Some will say that we can carry 180 kg. Correct now? So that is their power. So power is exactly how much beta. So electric power is what? The rate of doing work. What is the electric power? The rate of doing work. So right about electric power. So if somebody will be asking you about electric power, the rate of doing work is called power. In simple way, what we are going to write? Rate of doing work is power. I hope you might have understood. So rate of doing work is considered as power. And electric power is electrical work done per unit time. But somebody will ask what is electric power, right? What is electric power? So if someone will ask what is electric power, then what you are going to say? Electric power is the electrical work done per unit time. Electric power is the per unit time. Electric power is the electrical work done per unit time. What is electric power, beta? Electrical work done per unit time. Understood? So how we are going to write? Power is equal to work done, work done by time. So that comes under electric power. And how we are writing it as beta? We are writing power is equal to W by T. Note down what is the formula for power, ha beta? Wrote done. So I wrote down. Work done per unit time. And definitely with the electric power, when somebody will be asking you, so power is equal to work done by time. What is electric power? Power is equal to work done by time. Understood? So what is the electric power unit? What is the SI unit? Directly SI unit, work done unit is joule and type is second. So SI unit is watt and written as W. That means W, 1 W is equal to 1 joule by 1 second. 1 watt is equal to 1 joule by 1 second. 1 watt is equal to 1 joule by 1 second. Absolutely. So, beta, that is the definition. So, if somebody will ask what is the definition of power, so you will say that the power of 1 watt is the rate of working of 1 joule per second. So, if somebody will define 1 watt, define 1 watt. So if somebody will say define 1 watt, then what you are going to write? Define 1 watt. If anyone asks you define 1 watt, what you are writing? Definition of 1 watt. The power, the power of 1 watt, the power of 1 watt is a rate, is a rate of working, is a rate of working of 1 joule in 1 second. Understood? It is the rate of working of 1 joule per second in 1 second, or per second also you can say. But we will write 1 second or per second. Okay, so 1 joule per second. So rate of doing work, how much 1 joule of work is done in how many seconds, beta? 1 second or per second. That is exactly the definition of power. That is the definition of power. Now, power will be exactly what it is. Power is what? See, the rate of doing work is considered as power, but power is always considered as the intrinsic energy. Understand or not? The energy. How much energy will be there? According to that, only work will be done. That's one of the most important thing. So now we are just going to understand 1 kilowatt hour will be equal to what. So this we have understood about the power. One section we have understood. So now 1 watt, 1 kilowatt. How much it will become? So if somebody will say 1 kilowatt is equal to 1000 watt. Note down 1 kilowatt. K will be small, W will be capital. So that's considered as 1 kilowatt. So 1 kilowatt is equal to 1000 watt. Now you need to understand one thing. Many times now, yes, 1000 watt. So what is electric power? See, power cannot be only associated with one work. Okay, power cannot be only associated with work done. We can say that power can also be associated with one more important factor, beta, and that is electrical work done. Understood? So electric work done. Here we are talking about what? Electric work done. So when we talk about electric work done, so here how much is the work done when that much amount, a particular amount of current is flowing in the circuit. Understood? So here how much amount of current flowing in the circuit also depends upon the potential difference. Understood? So if potential difference is less, then definitely work done cannot be more. We cannot be able to say that this is the amount of work done when potential difference is less. So that means what we can perceive here is ki how much work is done. It totally depends upon potential difference and amount of charges that is present in the circuit. It's not only potential difference. Means potential difference generated is there. Means according to the potential difference, because what is the formula for potential difference, beta? The formula for the power is equal to work done by time. This is one factor. Correct now? Now what is potential difference? Potential difference is equal to work done by amount of charge. Correct now? Huh? So what will be power? Power can be written as VQ by T. Now V is equal to IR. Can I write like this? Huh? Can I write like this? Huh? Can I write like this? Because we have all connectivity. We have all connectivity and we have exactly connected. So potential difference is equal to work done by amount of charge. So what we did is we wrote that work done is equal to V into Q. We wrote this part. Now V is equal to IR. We wrote this part. Done? Huh? We wrote this part. Now one more formula of current is there. Do you know what is the What is the formula for current? What is the formula for current? I is equal to Q by T. So here Q by T is there. Come on, check. We can derive on our own. I is equal to Q by T. So P is equal to I square R. P is equal to I square R. So definitely we derive the formula on our own. We derive the formula on our own. P is equal to I square R, or I square R. P is equal to this. This is exactly the derivation. And next class I am going to tell you how to derive the formulas. I hope you people might have understood what and all I taught. So definitely you might have liked the class what I taught today, numericals and everything. But how was the session? Was the session okay? Yes, today one more time you see the video, and actually one more time I'm going to explain all these factors. So just as a rough sketch I have done. In next class, I want everybody, yes, I want everybody to be present in next class so that you people will be able to understand what and all things we have to do. Okay, beta? So now in next class again. So today evening I think uh, today evening, yes, because area related to circle I'm going to teach. So I will not be giving invitation. Children, please join the session today evening also. Okay. Bye, everyone.